Welcome back to the tutorial course on Android app development. In this lecture, we will discuss views. We will also discuss different types of layouts such as linear, relative, and frame, and use them in the context of app development. As discussed earlier, a layout defines a visual structure for a user interface in an activity or a widget. This means that we see a single screen of an Android app, which is a layout XML file that we load inside an activity. We can declare a layout by using two different methods. In the first method, we declare the UI elements in an XML file, which is located in the res/layout/ directory. In this XML file, we define the components such as edit text, button, and list view. After we define the components, we need to load the XML file using the activity class. Using the second method, we can instantiate layout elements at runtime and load them in our application. The Android framework gives us the flexibility to use either or both of these methods for declaring and managing the UI of our application. We can create the XML layouts for different screen orientations, device screen sizes, and languages. In addition, when we declare the layout in XML, it helps us visualize the structure of the UI. As a result, it becomes easier to debug problems if there are any. The following are the layouts provided by Android that we will use in our app: linear layout, relative layout, frame layout. We will discuss each layout in detail in the subsequent slides. Linear layout arranges its children in a single direction, which can either be vertical or horizontal. We can specify the direction using the Android orientation attribute. We can set the layout direction using the set orientation attribute. In this attribute, we set the orientation of the child elements as horizontal or vertical. For example, the following code snippet depicts the element to be vertically aligned. Android orientation equals vertical. We use the Android orientation attribute at the time of using the linear layout inside an XML file. Using the Android orientation attribute, we can set the orientation to horizontal or vertical. However, if we want to programmatically create the layout, we need to use the set orientation method. Similarly, we can also programmatically define the alignment of all the child elements by calling the setGravity method. On the next slide, we will learn how to create a linear layout and become familiar with its attributes. Using Android Studio, we can create a home activity in our app. Let's open the activity_home.xml file. In the homeactivity.xml file, we have added a linear layout and the required width and height. By default, inside a linear layout, the orientation is horizontal. Now we add the three buttons, which are now shown as horizontal. We can now align these buttons vertically. For this, first we need to set the orientation to vertical. When we check the design view, all three buttons are found to be aligned vertically. We need to set the gravity attribute of each button to bring it to the center. The linear layout has a parameter called the weight attribute. We will need to assign a value to the weight attribute. A larger weight value allows the child view to expand in order to fill the remaining space in the parent view. In this code, we set the layout weight attribute for the first button. Now, when we check the design view, the test button 1 is seen to have used the remaining space in the linear layout. After assigning the value for weight attribute for the test button 1, we assign it for the remaining buttons. If we now check the design view, both button 1 and button 2 equally use the remaining space in the linear layout. If we give the same weight to all three buttons, all three of them will take equal space. Now, we need to give button 1 with a weight of 1, button 2 with a weight of 2, and button 3 with a weight of 3. If we check the design view, button 3 takes more space since its weight is more. Similarly, others take the space according to their weight. Similarly, we can design different view components in the linear layout. On the next slide, we will discuss the relative layout. Relative layout displays child views in relative positions. In this layout, the positions of the child views can be specified in relation to each other or to the parent view. The position of each view can be specified as relative to sibling elements, which can be located to the left or the bottom of another view, or in positions relative to the parent relative layout area, such as aligned to the bottom, left, or center. A relative layout is a powerful utility for designing a user interface because it can eliminate nested view groups. This helps in keeping the layout hierarchy flat, which further enhances the performance. Consider the following important properties of the relative layout. Android layout align parent top. We set this attribute to true when we want the top edge of this view to be aligned to the top edge of the parent. Android layout center vertical. We set this attribute to true when we want the child view to vertically center within its parents. Android layout below. We want the top edge of this view below the view specified with a resource ID. Android layout to the right of. We want to position the left edge of this view to the right of the view specified with a resource ID. All these properties are available only if the parent view is a relative layout. On the next slide, we will learn how to create a relative layout. In Android Studio, open the Activity Home layout file. In this file, we will create a relative layout with the required width and height. We will now add the child elements. Let's create a sample login screen. First, we will create a title for the screen with a text view inside the relative layout as login. We set the required attributes similar to a text view. Next, we create a username text view below the login text view. We use the layout below attribute to place it below the login text view. This attribute will be available if the parent view is a relative layout. Similar to the login text view, we will set the attributes for the username text view. Then, we will add edit text to the right of the username text view and below the login text view. We will also set attributes for edit text. The desired output is displayed with respect to the views and various relative properties. We are able to position the child views relative to the position of other view or the parent. Let's now add password text view below username text view. Create password text view and give width and height. Set an ID for this view and align it below username text view. Give the required size for the text view and required margin. Create a password field to the right side of this password text view and below the username field. Set the ID and the required margin. Add a login button below this password field. Position it to the center of the screen. If the layout center horizontal attribute is set to true, the view will be horizontally centered. Add a sign up button at the bottom. Create a button and set the width and height. Position it at the bottom of the screen using the align parent bottom attribute. Center it horizontally and give it the required margins. Now, if we check the design view, we can witness how it appears. Our sample login screen is now ready. For simplicity, avoid creating all these views manually. In the design view, you can drag the required views to the screen. All the views are positioned with respect to each other in the relative layout. Let's now discuss the next layout called frame layout. Frame layouts are used by Android developers to organize view controls. A frame layout is considered a container layout that displays a single item by blocking an area on the screen. Usually, we use frame layout to hold a single child view. This is because it can be difficult to organize child views that are scalable to different screen sizes. If there are multiple child views, they are bound to overlap each other because of their scalability according to the screen sizes. We can, however, add multiple child views to a single frame layout and control their position by assigning gravity to each child. We can assign gravity with the Android Layout Gravity attribute. A child view within a frame layout is always drawn relative to the top left corner of the screen. We can use the frame layout if we want to overlap different views. On the next screen, we will learn how to create a frame layout. Open the activity home.xml file in Android Studio. Let's add a frame layout as the root element. Then, we will add width and height to this layout. We will use fillParent as a value for both of the attributes. Now, we will add image view as a child to frame layout. We will then define the width and height attributes and the layout gravity attribute. We have added only one child view inside the frame layout. Let's now add a text view inside frame layout. Similar to image view, we will add the width, height, and gravity attributes. We will next add the text size and text style attributes. Let's check the design view. We can see both the child layouts inside the frame layout. Similarly, we can add multiple child views to this frame layout and control their position by assigning gravity to each child. The app shows that the image view and the text view are overlapped. We use a frame layout if we need to overlap views. This brings us to the end of our discussion on layouts.